Welcome again, Wildcats. So today we're looking at Monday, October 16th, solve 2 and 3 systems with matrices. And that's going to be on page 21. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, so on page 21, solve 2 and 3 systems with matrices. To solve systems of equations with the inverse, you first write the matrix equation AX equals B, where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. So if you would pause and update that part of it. All right, now with that said, let's look at a matrix equation representing. So 1x plus 1y equals 8 and 2x plus 1y equals 1 is shown. Okay, so that means A is 1, 1, 2, 1, X is XY, and B is 8, 1. Okay, to solve AX equals B, multiply both sides by the inverse A inverse. So AX equals B, A inverse times AX equals A inverse B, and A inverse times A is 1, so 1x equals A inverse B. So if you would, finish up your notes now. All right, now your notes are updated. Let's take a look at our examples. Now continuing, I'm doing it the last couple videos or last video. So I'm going to go over all the examples for those students that once they see the video, they can start working on the assignment, okay? All right. Solve the system's equations using the inverse property of matrix A, okay? So the first thing we're going to do is convert these to matrices. So this is 2, 3, 4, 3. And this is matrix A times XY. And that's times X equals 12, 12. And that is equal to B. All right. Now, once you have that, the next part is we know that that's AX equals B. So we know we need to multiply both sides by A inverse. So A inverse A X equals A inverse B. Well, this becomes A inverse A is just X. X equals A inverse B. All right. The next phase is now we need to actually put the matrices in this form. So we know X is XY equals A inverse is 2, 3, 4, 3 inverse times B, which is 12, 12. So at this point, you want to plug that into the calculator. All right, so you go to on, new document, no, add calculator. Now, almost forgot, before I start, if you don't have a calculator with you while you're watching this video, what I recommend doing is just at this point, put your pencil down, just watch as I walk through the steps, and then when you go to class on Monday, you can grab a calculator and you can finish that part of your notes up. If you have a calculator, just follow along with me, okay? All right, so to put this in a calculator, first off, you don't need to put X, Y in the calculator. You just need to put the right side, okay? So you're going to press this button right here next to 9. That gets you the matrices, this button right here, okay? And you're going to pick this option right here. Okay, once you've done that, then you look at This has 2 rows, so that's 2. I don't know why, but you have to press tab. If you don't press tab, it won't go to the next box. So press tab, and it has 2 columns. Press enter, and then you're going to do 2, 4, 3, 3. Now to get the inverse part, you're going to press this button right here, okay? But you have to click to the right, get out of the matrix, and so then you press this button right here to the -1. Click to the right, times, you're going to press the button next to 9 again. That's the box you want. Now this is 2 rows, not 32, 2, tab, 1 column, press enter, 12, 12. So basically, before I press enter, what I'm showing you is, we've already showed you algebraically how to solve a system. Now we're showing you how to use the calculator to solve a system. So your answer is 0, 4. So that equals 0, 4. That means x equals 0 and y equals 4. And you need to actually write that, what x equals and what y equals. All right, so let's finish up that, and let's look at example 2. All right, so example 2, again, we're going to convert it to matrices. So this is, A is 2, 3, -4, -6, times xy equals 12, -18. So this is A, this is X, and this is B. All right, so we know that AX equals B. And you can actually, I'd be okay on a test if you didn't write this line. You could write from this to this. X equals A inverse B. Okay? So now, we want to plug the matrices. So this, we know X is XY equals A inverse, which is 2, 3, -4, -6, inverse times B, which is 12, -18. All right, so at that point, you want to plug this into your calculator, okay? So new document, no, add calculator. You're going to press, again, the button next to 9, this button right here, that box right there. Now, A is 2 rows, 2 columns, so 2, tab, 2, and so that's 2, 3, -4, -6, click to the right, click to the right. This button right here to the -1, click to the right. Press the button to the right of 9 again, press enter, and matrix B is 2 rows, tab, 1 column, enter, and then it's 12, -18. Now at that point, if you get the message singular matrix, the solution is either going to be infinite solutions or no solutions. But the calculator's not going to tell you, so you're going to have to go back and solve it algebraically. Okay? So to do that, we're either going to use substitution or elimination. Okay, in this case, it looks like we're going to use elimination because both equations are in standard form. Now, I'm looking for a positive negative combination, and I always usually look at the first term first. So here, this is positive negative, that's what we want, but here we want these to be both 4. So if we multiply the first equation by 2, this will give us a 4x, okay? Remember, this is equation 1, this is equation 2. So equation 1, if we multiply everything by 2, is 4x plus 6y equals 24. And that's negative 4x minus 6y equals negative 18. Well, the x's cancels, the y cancels. You're left with 0 equals positive 6. If you're left with a false statement after both variables eliminated, you know it's a no solution. No, it's no solution. All right, so finish up example 2. All right, let's look at example 3. Okay, so again, we know that matrix A is 2, 3, negative 1, negative 1.5. Okay, times, you don't actually have to put a dot if you need to write this, xy equals 12, negative 6. And again, that's A, x equals B. All right, so again, we know that A, x equals B. So we multiply A inverse by both sides, you get x equals A inverse B. And at that point, you want to write that down in matrix form. So that's x is xy equals A inverse is 2, 3, negative 1, negative 1.5 inverse times 12, negative 6. All right, at this point, you want to plug that into your calculator. And at this point, I think I've shown you where the buttons are enough that we can just go through here. So we press click to the right, the button next to 9, press enter. We know it's A is 2 rows, tab, 2 columns. So 2, 3, negative 1, negative 1.5. And now we're pressing the button below the equal sign to negative 1, click to the right, the button to the right of 9, enter. B is a 2 row, tab, 1 column, 12, negative 6. All right, so again, we get singular matrix. If you get singular matrix, your solution is either going to be infinite solutions or no solution. So now we're going to solve it by hand or algebraically. All right, so I see the negative here, okay? There's a positive, so it's probably want to multiply something by the bottom equation. And it looks like 2. If I multiply 2 times negative 1, I get negative 2, the x's will cancel. Okay, so we're not going to do anything to equation 1. We're going to multiply equation 2 by 2. So that's 2x plus 3y equals 12. Multiply everything by the equation 2 by negative 2, so that's the equation 1, equation 2. So you get negative 2x minus 3y equals negative 18. Oh, whoa, not negative 18, negative 12. Okay. Well, the x's cancel, the y's cancels, and the 12 cancels. You're left with a true statement. So we know that the solution is infinite solutions. All right, so at this point, you've seen how to solve a matrix or a system using matrices with one solution, no solution, infinite solution. Now, at this point, there's 15 minutes into the video. It's probably going to take another 5 minutes to do example 4, but here's the thing. Example 4, the only reason we have it is because this is a 3x3 matrix, okay? But the work is the same, and it really doesn't matter because you're using a calculator, okay? So if you want to stop, if you understood example 1, 2, and 3, you could really start working on the assignment. But if you want to see it by a 3x3, then you can go ahead and watch the video 4. If not, you can just start working on assignment. Just remind me when I'm doing a journal check that this, if you didn't do example 4 on this page, it's not incomplete. You just didn't really feel like you need to do that. All right. So same step, really the same steps with the 2x2. You have your matrix A. So 2, 3, 1. If there's not a number, put a 1. 4, 3, 1, negative 3, 4, negative 2. That's your A matrix times x, y, z equals 17, 17, 6. So still works the same way. AX equals B. Multiply both sides by A inverse. So X equals A inverse B. So X, Y, Z equals 2, 3, 1, 4, 3, 1, negative 3, 4, negative 2, inverse times B, which is 17, 17, 6. Okay, so at that point, we're going to plug in the calculator. So then you're going to press the button to the right of 9. There's 3 rows, 3 columns, press enter. 2, 3, 1, 4, 3, 1, negative 3, 4, negative 2. Click to the right. It's a negative 1, not that negative 1. Click to the right. Time. Now that's going to be the button to the right of 9 again. Now that's 3 rows, 1 column. Press enter. 17, 17, 6. And that equals 0, 4, 5. Okay, so you got to remember to write your answer. So x equals 0, y equals 4, and z equals 5. Now, if you're one of those ones watching at home, you don't have a calculator, here's the thing. What I would recommend doing is setting up all your problems from your assignment, and then you could do the calculation portion when you get to class, okay? So with that, have a matrix of a Wildcat day.